In both of these examples, we were determining an energy usage as compared to the amount of square feet that the energy was being used. There are other indexes that we could use to do that with, and it's shown here in tables 1-3 and 1-4, which are coming up here in just a moment. Yeah, so here on 1-3, we're going to see, well, one thing we could do is we could talk about the amount of BTUs per unit of production, or we could talk about the BTUs per degree day, and we're going to talk about degree day more in Chapter 2. We could talk about BTUs per square feet, or a combination of them. So there's advantages and disadvantages pointed out here on this page. On the next table, we're going to see some proposed ones where we could say, well, we could do it this way or that way, and again, the advantages of them. So we'll look at several of these. In this case, they're going to be comparing the BTU towards the sales dollar, or the amount of energy, actual cost of the energy. Or finally, we can calculate it towards direct labor. We could connect it to machine labor, and so forth. Regardless of what index is going to be used, we're going to have to measure it, and we'll have to develop some sort of an energy budget. This book talks about two different types of budgeting. One is called a statistical method, and the other is called the engineering model. We're going to see both of these and some formula for both of them here in a couple more pages on 35, right? And the statistical model is going to use this table 1-5, and notice it's going to be looking at both the energy units, the production, the square feet, and the degree heating days. So we can design this whichever way we want, and we're going to see that there's a statistical formula here. This is the first formula. Notice they put formulas in here on the right side, 1-1, and in this case, we're going to be comparing it to degree days, and then later on at the bottom here, we're going to see formula 1-2, where we're going to add these together. So the thing about the statistical method is it's a pretty big beast, and even the authors say here that it's sort of outside the scope of what we want to cover here in this book. So we'll talk a little bit more about the engineering model, which starts here on page 36. And we can see that some of the advantages to this include improved accuracy and flexibility in reacting to changes in building structures, production schedules, and so forth. Which then brings us to the reports. So we're going to have to write reports. And these reports will help us to understand and detail variances in, for example, one variance could be the cost of the fuel. Other variances could be the weather, could be curtailment caused by suppliers. There are many reasons we could have this, and we have to be able to report these. So coming up here, we have an example right here. Not this example right here. This was, it's listed here in example 1-3, and it's explained on the page before. So what happens on this page is the heat treating department of I don't know, maybe they make lawnmower blades. I don't know what they make. So they have a budget. They budgeted for a certain amount of millions of BTUs, and they determined that, of course, they had to calculate it to the BTUs for their electricity cost, their gas cost, and their steam cost. And we can see that their budget was $33,500. And you can see these other categories and columns that are listed here. When they budgeted, they thought that it was going to cost them $4 per million BTUs of electricity, $2.50 per million BTUs of natural gas, and $3.50 for the steam. But in reality, all three of them went up significantly, as you can see right here. Well, the good news on this is that not only were we thinking ahead and coming up with a budget, we were also trying to find ways to reduce the amount of energy use. So notice the budget also includes that they had 2,125 million BTUs of electricity use scheduled. You know, that's what they thought they were going to spend. Well, they found a way to trim it by a significant amount. 125 million BTUs were trimmed off of that. Same thing happened in their natural gas cost and in their steam cost. So, although they budgeted for $34,000, and they budgeted for $33,500, they spent $500 more. But had they not followed through with the energy use, or with the energy savings, and used the budgeted amount of energy use, it would have cost them an additional, it's $7,000. It was the amount of cost savings that they had. So we're going to spend some time looking at ways that we can measure, monitor, calculate, and report energy use and savings for the remainder of this chapter. The first term that jumps out is this term called Q-sum, which is the cumulative sum of the differences. And that's going to show up right here on page 39. Okay, so the Q-sum, and I've got this key phrase here, analysis of variance, right? I've got a note right here. And that note is, it's also known as ANOVA table. And I will post a link on the Blackboard for some resources on how you can learn more about these ANOVA tables and this analysis of variance. What it amounts to is what's referred to as a regressive, where is it? A pattern of regression is what they call it, which is sort of the wrong way to look at it, because it's not really regression. And I'll explain a little bit more of that in another video. So we'll be looking at the energy performance models using this statistical math. And we're going to do it a couple ways. I imagine some of you have read this and may have been a little confused or felt like the textbook left a little to be desired as far as clarity. I think it assumes that we've all got some experience using statistical mathematics, which probably most of us don't. So I'm going to record, or I have recorded, a couple other screen captures, and I found some YouTube videos that are going to be of great assistance when we're trying to answer the assigned problems. There's going to be two methods that will be studied, and they're shown here. I'm going to move forward. Bear with me. One of them is heating degree days. Okay, so I've highlighted this, and again, we're going to be going over this in greater depth next chapter here. So heating degree days for the winter season include the difference between the outside temperature and a baseline. The baseline is typically 65 degrees Fahrenheit or 18 C. And likewise, we'll also have cooling degree days. And that will be, the baseline for this is typically 72F, there's a typo right here, or 22C. So we'll learn more about that here in a bit. But what we'll end up doing is we're going to be looking at the functional relationship between energy and the independent variables. So here's our next formula, right? This is the one we're going to use for the degree day calculations. This is a type of linear equation, right? And this linear equation is going to allow us to see how variances of one thing can be calculated to cause similar variations in another. And so it continues on to the next page, and it explains the different components of the formula. And lastly, we'll be able to also use these same types of formulas. Here's formula 1-5. It's a linear equation, and we'll be using that based on production. So not just on the temperature, but also on how many pounds of something that we make. And so we'll spend a little bit of time going over that. But for now, I'd like you to finish reading the chapter and make sure you have a look at the other two videos, which are going to show us how to calculate these formulas.